So what are type classes? So until now, so let's see. Until now, we learned about. Right. So what do we know? We know that there's types, right, which we can introduce with type or data, and so on, right? We know there's functions, right? Like things like int to int or whatever, right? We know there's functions, and that's kind of everything we like. Big picture, this is what we've learned, right? We learned like, and records are also types, some types, product types, function types actually also types, but like functions are a bit special, right? But then there's one more thing that's called like one thing. Well, there's a few other things, but there's one other concept that we have not talked about, and that's type classes. So let me give you an example of a type class, right? Before anything else. So let's see, if we kill prelude, what will fail here? Let's see where do we use prelude? So we use it for plus, which is fine, and we use it for show, I think, which is unfortunate because that's, well, no, okay, so we could import prelude and just import plus, and then what was it? And then this. Let's see, what else do we need? I'm just trying to not import everything because I want to redefine something. Right, and we have show here. Okay, you know what? We'll just use a different name for it. Okay. So what's the syntax for type class? Well, we write class, and then we show, we give it a name like print. It's just a name. And then we say print and then some a, something, right? And then we do where. And then let's say print goes from a to string. Okay, so how do we read this? What does this mean, right? So we're saying that there exists some property print. Let's call it property for now, right? For types, for a type A, right? And this is a variable here, right? So for some type A, and if this A has this property print, then it has this operation that we can go from a to string. Right? Does that make sense? And let's call this print prime just so we don't overlap the names here, right? So for example, what can we do? Well, we can say instance, and then we can give it a name, and we usually do print int, for example, and then we can say print int.
Mm-hmm.
Right, so this is kind of like if you think in OOP terms, which is might help you now, but don't get too stuck up on it because it's not really the same thing. But this is kind of like an interface, and this is kind of like an instance for it, right? We're saying, okay, so for whatever type A can implement this print interface, right, or like property, then it needs this function, right? And then here we're saying, okay, for in case of int, this property is implemented using show, right?
Yeah.
And then we can write more instances, right? You can say instance, print, even string, right? And you can say print goes from string to string. You can say print s equals just s, right? For example, because that's fine. Or you could also do show s. The difference would be that, well, you'll see, it doesn't matter that much. Right, and you can do instances for all sorts of things, right? You can do for any type that we declare. Okay, important. You can't declare instances for types, for aliases, just for the types that we create manually for ourselves, right? Not for types. Okay. So this is one example of an instance, right? And actually, so if we look at show, so give me a second. I'll get to that question in chat in a minute. Sorry, let me finish my idea. Okay, so this print here is actually exactly what show does, right? So let's look into the REPL again, and let's do type show. I think it's what we need to do. Right, so if you look at the type of the show function that I have in the REPL here, I'm not sure, can you also see it on your computer, or can you only see it on stream?
I can see it on my computer. So
Okay, cool. So if you look at the type of show, you'll see that the type of show is for any type A, right?
yeah.
And then you see the show A and then this fat arrow, right? This equal
Yeah.
greater. That's not like the usual arrow, right?
Mm-hmm. Yeah.
This is basically saying us that the type A needs to have this show class or an instance. So this means that if we want to call this function, right? If this is to work, then A needs to have a show instance. Right?
Okay.
So let's try here to use print, for example, right? So if we were to use print on, so let's do test, right? So test is string. So if we want to say test equals to print true, which is a boolean, right? We'll get an error here, which says that, hey, you don't have an instance for boolean.
Yeah.
Right? Because we only have for ints and strings, right? So let's comment this out and say, this will fail because we have no instance for boolean. Correct?
Yeah.
Okay. Then, and same goes for show, but then show has instances for most things, right? So it's going to be hard to show exactly how that doesn't work. But then we could, for example, write, let's see, write a function show, print. Actually, no, that doesn't matter so much. Let's focus on type classes for now. So let me think. How do I... Okay, can you try... Okay, let's do something here. And then that will probably give me some time to answer the question in chat. You can write true with a lowercase t. Yeah, so in Purescript, the Boolean values are lowercase rather than Haskell, right? So true and false in Purescript are lowercase true and lowercase false, whereas in Haskell, they're true and false with like capitalized names. But in Purescript, so there's no... you can't choose, like they have to be lowercase in Purescript and they have to be uppercase, well, capitalized in Haskell. Okay, so let's see. Do I want to go into that? No, let's do something else. Let I construct. No, only for booleans, which is a bit confusing maybe. But the reason it's like this is because true and false are the same true and false as in JavaScript. Is it that? I mean, that's one of the reasons, I guess. But only boolean has that property. All the other constructors are capitalized. That's a bit weird. I agree. Okay, so let's write data my type equals to my type int here. So do you think you can write a show instance for this? You want to try? Sorry, a print instance for this.
Yeah, sure. Just go ahead and answer Mr. Hazy's
Yeah,
question.
I'll mute so I don't, or do you not care?
What?
I was going to mute on Discord. Do you or you don't care? Or you
No, it's fine. I actually want to listen to what you have.
Okay, cool. So yeah, if you can focus on writing this,
it's
fine.
fine.
If you can't, then we'll get to that in a second. So I'm looking to get into programming, software engineering. I was going to start by learning Python, then working my way to JavaScript, and then to Java, picking up HTML along the way. My question to you are this: is my pathway of language a good path to take? Am I hindering my ability to get jobs by going the self-taught route? No, I don't think so. I think the vast majority of programmers are self-taught. So you're definitely not hindering your ability. I think Python is a good language to start with. So again, it really depends what your goal is, right? If your goal is to get into software engineering and get that get a job in software engineering, then yeah, Python or JavaScript are probably your best bets in doing so. Good night, Gil Christian. Thank you for dropping by. So yeah, that's a totally reasonable path. I don't think you need to learn JavaScript, and I definitely don't think you need to learn Java unless you want to. So yeah, that's my take on it. Just go with one language and learn it and start applying to jobs. Right, but again, like you need to understand that it's probably going to take you some time, and then you need to like put in a lot of hours in like just writing programs to get somewhere. That's pretty much all it takes. Can you have unnamed instances? No, you need to. I think that's a proposal, and I think that might be changed soon in the compiler. But for now, you need to always name the instances. Okay, so let's see what's the problem here. Okay, so the problem is you need to do an instance for my type, not for int, and you typed int here, right? Here.
Yeah.
So this needs to be my type instead of int, and then this also is my type.
Yeah.
And then okay, so you can't really show my type, right? You can show ints, but this I is of type my type, not of type int, right? Because like it's this, so you need to pattern match basically here, like on the left hand side where this
left,
I is. Yeah.
So it like it would be like this.
Yep, I think that's correct. Let's save. And yeah, that's good.
Now I have it.
Okay, you wanna try? Let's try one more. Sorry. Not sure what I'm typing here. Int and string. Let's do this. Okay, wanna try this as well?
Yeah.
Okay. Cool.
Okay, so
let me do the next question. So JavaScript and Java were to serve as resume boosters and allow me to take side gigs in front-end coding for website development. So again, if you already know some programming, you can definitely, like if you already know C or C++ or whatever, and you're finding that it's hard to find jobs with that language, then yeah, sure, by all means, learn as many languages as you want, because it's probably not going to be hard. If you don't know any language, then learning one language, I'd probably think that learning one language, like going depth, is better than wide in this case. So like if you want to do like backend stuff and like data science and things like that, then Python is a good language for even like generally Python is a good language. Yes, Sky. Purescript has first-class records, and they're way nicer to use than Haskell's. Yeah, that's one of the main like Purescript you can do so much in Purescript with records. They're very nice to use. Yeah. So again, like Mr. Hazy, if like my recommendation is to go deep in one language, just pick one and go deep. And JavaScript is good. Yeah, I mean, the idea is that if you, how should I phrase this? So if you learn one language very well, like go deep, then it's not going to be hard for you to learn other languages. But if you don't go deep and if you like learn a bit of Python and then try to learn a bit of JavaScript, that's going to be almost as hard. Right, the second and the third and the fourth might be almost as hard as the first one. Whereas if you go really deep and really understand how to write programs in a single language, then it's like learning the second language should be pretty easy, and then the third should be way easier. Right, and it's only going to be harder when you try to learn different paradigms like functional programming, which is what we're doing now. That's always going to be hard unless you already know one functional programming language. And then OOP might be a bit tricky the first time you try it, and so on, right? But similar languages like JavaScript and Python, like Java, C#, and whatever, C++ will be very similar. And if you learn one, then it's not very hard to learn any of the others. So yeah, I definitely recommend just learning one language really well, or as well as good as you can, and then applying for jobs within that language and getting some like professional experience with that one language. Okay, cool. So yeah, this is correct. Good job. Okay, so then let's look at other examples. So okay, this is show, right? And okay, so we called it print here, but this is show, and it's basically the same, except instead of print, it's called show, right? And this already exists. It exists for all the types you can, almost all the types you can think of. And if you create a new type like this, then you can define the show instance exactly like you did here, right? Except you say show here and then show here, right?
Yeah.
Yep. Yeah, good. Yeah, I think that's a good thing to do, Mr. Hazy. And there's a few Python streamers, I'm sure, on this website. I only watch functional programming streams, so I wouldn't know, but I'm pretty sure there's quite a few of like Python and JavaScript streamers on Twitch. There's a lot of material you can use to learn, and yeah, good luck. Good luck, and like just make sure you write a lot of programs as you learn. That's how you learn. You don't just watch or read books or whatever. Just write as much as you can. Write code and get it wrong and fix it and whatever. And yeah, thank you for the follow. Okay, so let's continue. Okay, so let's do another type class, right? So this was show. So there's another type class that allows us to compare things, right? So, or rather to see if two things are equal. And we'll give it a different name here just so you see how it's implemented, but then I'll tell you what the actual name is, right? So let's say it's equal a, and then this has one function which is called eq equal a goes to boolean. Does this, wait, sorry, I forgot where here. Does this make sense?
Yeah.
Right, so I can test whether whether I can have the equal property on a if I tell the compiler if two things are equal, right? This is true or false, right?
Yeah.
So for example, instance equal oh, by the way, one thing before we go on. So you used show int here, right?
Yeah.
But you'd usually do print, right? Kind of like recursive in a way, but it's not really recursive because it uses a different instance. It uses the instance above, right? This one. Right, we're kind of cheating because you're using show here, but then if you're doing things that are more like complicated, we'd probably just use print to combine them, right?
Yeah, I get it. Yeah.
Okay, cool. You'd probably also do something like print int here or something, string or something, right?
Okay.
But again, your version works just as well, and just like okay, so let's see. So we could do something like let's see, instance what's it called, int, well, equal int. Again, you can type whatever you want here, it doesn't matter, right? But usually I usually see this, right? The name of the class and then the name of the type, right? Where equal goes from int to boolean, right?
Yeah.
And then of course you can cheat and say x equals y, right? Because we're not going to do it like from nothing. And then equal, I don't know. Okay, that's enough. We don't need to write more than that. Okay, so can you write an instance for my type 2 for equal?
Yeah. Okay, so, and you said that it's the name of the class, which was my type 2.
No, the name of the class is equal.
Equal.
Yeah, and then the type, right, which is my type 2.
My type 2.
Okay. Why int?
Was thing? Wait, where is my type 2?
It's just my type 2. Like, it's going to be very similar to this, right? So you need to type equal and then my type 2, right?
Yeah.
Okay.
And now I have
yeah, that's good.
It goes to a boolean again, but no, goes So my type 2. Okay,
Yeah.
so I know for sure that the output is Boolean,
Mm-hmm.
and
Like essentially have to like your
int and string. Right?
no. Wait.
No.
So
So
okay,
this is
let me show you a very mechanical way to write an instance, right? So let's
yeah.
copy this thing. Like I'm copying this, right? The equal,
Okay.
right? And I'm pasting it here. Okay. So
Yeah.
I will replace class with instance, and then I do this, right? And then I put this here so I don't forget, right? So now what I do now, well, okay, let's see. I put a here and then, well, equal a. Okay, I type this
Yeah.
here. Okay, so now I take all of the a's and replace it with my type, right? So this is equal my type. This is equal my type, well, my type 2, right?
Yeah.
And then here is my type 2, and then here is my type 2.
So it compares my type 2 with my type 2,
Yep.
and I get the Boolean if they are equal.
Yep,
Okay.
exactly. Right, so like the idea is that you always compare same, like you always compare oranges with oranges, right? You never compare apple to oranges. That's the idea here.
Yep.
Right? So it needs to be the same thing. Okay, so how would you write the code for this?
Well, so I get. So well, we start with equal.
Yep.
So okay, let's say int and string because that's what I.
Well, you need to pattern match, right? Kind of like this.
Okay.
Okay. But then,
And
wait. So this pattern match is just for the first one, right?
yeah.
But you also have to pattern match the second one.
So I have to give it like
Yep, that works. Okay.
let's put the one.
Okay.
So do I need anything here in between them?
Nope, just a space.
Yeah. Okay. And now I get the both.
Okay, that's good so far.
Just 1 second. I have no idea what to do.
Okay, so let's think, right? So we're trying to see if these two things are equal, right?
Yeah.
But we have two integers and two strings, right?
Yeah, so I have to compare int1 with int2 and string1 with string2.
Mm-hmm. Yep.
Yeah. So I mean,
So just start with comparing int1 with int2. Okay, perfect. And then, okay, so what's the result of this operation? Int1 equals
this
equal.
is a Boolean, so it's true.
Okay, it's either true or false, right?
Yeah, yeah.
And then how, like, maybe add a space afterwards and put an underscore there or something, just so we remember we have to put something there, and then just compare the two strings, the other two strings.
Yeah.
Right, because you said that we need to compare both things, right?
Yeah.
Okay, so this is a Boolean and this is a Boolean, right? So
I need one Boolean out of.
So how do we? So what kind of operation do we have over two booleans? Like, what kind of operations are there for two booleans to go into a third boolean?
It's either or and.
Yep.
But I need and because both of them have to be.
Exactly. That's exactly correct. So I need to just put an and there. Yeah, and just remove the underscore.
Yeah.
And yeah, that's correct. That's the way you implement it.
Okay.
Right? It's not that hard.
Oh yeah, yeah.
Okay, cool. So that's equal. And in reality, its name is EQ, right? So this is class EQ in Purescript. So class EQ, and then this is called just EQ. And there exists an alias like this, which is the same as EQ, right? So that's why we can use this thing instead of EQ. And then okay, so let's do something. Let's define this. So how would you define not equal? Do you understand what the function should do?
Yeah, it tests if they are not equal. So I would just
Actually, no.
make
That's very mean because you don't know how to do this. I've not told you how to do it. Let me show you. Right. So we want to do not equal.
yeah.
And we want to somehow use this equal, right? Because like, okay, again, this is a matter of how do we write the implementation, right? Because
Yeah.
we could say that not equal xy, right, is not x, well, equal xy, right?
Yeah.
I mean, that's simple.
Yeah.
So what's the type? Well, we can write something like this because we want it to work with for anything, right? So we could say for all a goes to boolean, right?
Yeah.
But if we say it like this, then it will give us an error. So let's see what the error is. The error is, okay, there is no class instance. Let me scroll down. So there is no instance for equal A1. And it's saying A1, but it actually means for A's, right?
Mm-hmm.
So you kind of say, okay, this only works if we have equal A. And then it works. Okay, so this is kind of the syntax where you say, okay, I want this function to work for any A, right?
Yeah.
But I want it to be equal, right? I want to be able to use equal operations on it, right?
Yeah. Okay. Yeah.
And then, for example, now I could say, so now you can say are equal, well, some tests, that's a boolean, and test, we could say not equal 1, 2, right? And why does this work? Well, how does the compiler know? Well, it tries to run this thing, right? And it says, okay, A is int, right?
Yeah.
So do we have an equal instance for int? Well, yeah, it's here, right?
Yeah.
So it uses this thing, right? And it uses this equal here, and then it does not over it, right?
Yeah.
But then if we try to do like this, it will say, well, no, you can't use this because there is no equal instance for string, right? That's what it says here.
Yeah.
Like
Yeah.
equal string doesn't exist, right? So that's how this works. Don't worry too much about it. We'll do a lot more examples of this. I just want to show you one here.
It kind of makes sense.
Mhm.
I think I got it. Yeah.
No, what I mean is, okay, don't worry in the sense that it's going to be hard for you to write functions like this, right? Understand how to write the signature for now. So I don't want you to be able to write them, but I want to be able to read them at least.
Yeah. Yeah.
Right? And to understand that, like, to read this carefully, and when you see fat arrow, understand that on the left of fat arrows are classes, right? And on the right of fat arrows are like inputs, right? And then the last one is the output, right? That's all that I need you to remember, right?
Okay.
In this case. Okay, so now there's one more class. A not equal spec will probably be part of the well, not really, because in Purescript you don't have minimal. So if you don't have minimal, then you'd have to implement both every time, and you probably could do that, but it's like, I think specifically, let me check actually, I might be talking out of my arse, so let's see. If I remember correctly, I think equal only has EQ, right, in Purescript, and then not EQ is defined as exactly like I did, as a separate function. In Haskell you have that minimal pragma, and you could say, like, you can either define EQ or not EQ, but in Purescript we don't have that. So yeah, I mean, right, I can, but then I'd have to implement both every time, right? That's the only problem, and that's annoying to do. Right? But I mean, definitely, you can definitely do that. That's not a problem. You can do it, and it will work. It's just that you'd have to define it manually for every function. And of course, you could have a like you could still keep this and say, like, call this default not equal, and then say not equal equals default not equal if you don't have anything interesting to do. But I think you can define it in terms. Let's test it, right? So let's call this default not equal. Okay, and then let's do not equal. A goes to Boolean, and then try to implement it here as equals not. And then we need this to be int goes to int. And yeah, it works, right? You can definitely do that. Right? So you can, but like you probably would not do that usually. Okay, let's go back to you have convention would be in the class definitions. Yeah, I don't think you can do that in Purescript. I don't think you can do. So this is something you can't do, right, in Purescript. It's just a syntax error. Don't even get a yeah. Right. So there's one more thing we need to do, which is comparing two values, right? Because okay, so we have equals, right? We have the equality test, but we are missing like what if we want to see if x is bigger or smaller than y?
Okay.
Right. So that's what I mean by comparing. So let's see. Let's start writing the class, and then we'll see we're missing something. So let's say compare a where compare, and then we have two things, right? And then what we put here, right? Because here we want to say that what are the three options? Well, one is like the first one is smaller, the first one is bigger, or they're equal, right? Those are the three options we have, right? There's three. But we don't have a type to represent that. So let's define a type, right? So let's say data compare result, maybe, right? Is either equals, right? Or greater or lower.
Low. Yeah.
Right? And then let's see, this is a compare result.
Okay.
Does that make sense?
Yeah.
Okay, so let's do instance compare, well, and let me write this, and then maybe you can try writing the next one or something, right?
Okay.
So you could do something like this. We can use ifs here, right? And we can use this, right? So if x is greater than y, right? Then we can say the result is greater, right? Else, if y is greater than x, then actually let me show you this syntax because this is a lot easier. So x greater to y equals to greater, x smaller than y equals to lower, otherwise equals to equal. Let me delete this. Right, so this is the same thing. Oops. Okay. Right, so you understand this, right?
Yeah.
Okay. So can you try? Let me think. What instance should I ask you to write? Yeah. So write the instance for strings, for example.
Okay.
See if you. Yeah.
So I would be comparing x and y again.
Mm-hmm.
That's what I'm gonna name them. So you said that I can replace ifs.
Mm-hmm.
But this time I only have different and the same. I don't have lower.
Why not?
Wait one. So
it's okay. Let me show you something. If you're not
they
sure
are
about something,
yeah.
can you see the console? You can see it, right?
Yeah.
So let's do A, B, right? Do you see the results in the console?
Yeah, it's true and true.
Right, so A is smaller than B and B is bigger than A. We could say Z is bigger than A for sure. We can say that, right? So, like you can compare strings, right? And it's
Okay.
kind of like
So,
lexicographical
indexes.
compare.
Yeah, okay, yeah.
Okay. Hey Anton, yeah, you actually. I'm sorry, you. Well, actually, we're doing type classes now, so you've just missed the beginning, pretty much.
Yeah.
Mm-hmm.
Oh,
Yep. So it's identical, actually, the instance, right? And
yeah.
like the thing with this is you need to give me 1 second. You need to indent them a bit. They can't be on the same column with C, right? They need to be a
Okay.
bit more to the right. Otherwise, it's an error. Okay, cool. So let me think. Can we make it interesting in any way? I mean, not in a way that's interesting for our use cases here. Yeah, that's probably going to be homework. Like, for example, we can write a compare for a list or something, right?
Yeah.
But that's not very interesting right now, because like that's probably going to be fun for a homework, but it's kind of the same thing. Yeah, so this is a bit harder to implement if we don't already have it implemented, right? Like we have here. But if we use this, then yeah, it's obviously pretty easy to do. But that's the idea, right? So let me tell you what the names are actually in Purescript for this. So this is, I think, I always forget. So I think that's called ordering. Yeah. Okay. Wait, why is it like this is not what I'm looking for. Let me look for ord and see what the result is here. So it's ordering, which is okay, it's a data type as well. Okay, so in Purescript it's also data ordering equals to let's see, what's the order? LT, GT, and EQ, right? Which is the same thing, they just preferred shorter names here, right?
Yeah.
And this is class ord A, right? Should I? Yeah, and I think there's one more thing I need to explain. So okay, there is one more thing that I should have done here, right? And I should have written equals a. I think it's like this. Although I might be wrong. Or sorry, it's equal. Yeah, there we go. So okay, what does this mean? So class EQA and ord A. So what does this mean? Well, this means that if you want to declare an instance for compare A, you also need an instance for equal A.
Okay.
Right? That's the idea. So int works, but string doesn't work. And it doesn't work because we don't have an instance for strings for equal, right?
Yeah.
So we just need to define. I'll just write it because it's it's pretty easy. It's just not really that interesting. So let's do it really fast. And then the implementation is the same, and then this works now, right? It's fixed. Right, so this is kind of like a prerequisite, right? You need equal to do compare. And this is also the case in Purescript, right? So if you want to declare an ord, which is ordering, which is like the same thing as compare, then you need an equal instance.
Okay. Yeah.
Okay.
It makes sense.
Okay, cool. So yeah, these are the most basic, the simplest type classes that we can define, right? It's show, EQ, and ord. These are the simplest things that I can show you. And let's see, is it next time? Let me look at the plan again. And yeah, next time I'll show you some other interesting type classes. So next time we'll also be talking about type classes.
Okay.
And I think we need to do and more numerics and booleans. So I think next time will be half math, half
Okay.
type classes, because these are like concepts from algebra, right? Semigroup monoids, hating algebras, and all of that. I won't go too much into the math because you can read that in other places that are probably way better at explaining this than me. But yeah, I'll try to just explain the basics, but we'll care more about the programming aspect in this case. Okay, and again, Purescript has some very, very like this sort of instances are so much nicer in Purescript than in Haskell. And if you get around to learning Haskell as well, you'll notice that in Haskell this whole thing is a lot simpler than in Purescript. But again, it's simpler but not as nice to use, unfortunately, once you understand it. Okay, so I think that's pretty much it. So I think the takeaway here is, let's see, records are will help you not get lost with complicated types, and I highly recommend you use records and play with them, and we'll have some homework with the records. And then type classes are one of the ways that you can write polymorphic functions, right? Because you can think of it as a polymorphic function, right? Because it's it works on more than one type, right? The same function works on you decide on which types it works, right? And you can define your own classes. Okay, cool. So let's figure out what the homework is. Oh, by the way, do you have any questions right now or not?
No.
Okay, cool. So let's say this is homework. So let's start with records maybe. Let me think. So what do we do for records? What kind of cool records can we do? Okay, let me show you something first before we do homework. Something that I was hesitant to do earlier, but I think it will allow us to kind of combine records and to combine records and type classes is into a kind of a homework which uses both at the same time, sort of. So let me show you something. So we used this type point, and let me do this so we can do this, right? Equals to x int and then y int, right? And we saw this work, and then using it was simply get x, and I think we need a few of these now for point to int, and then some p equals to p dot x, right? And this works, and we know it works. Okay, but if we do data point, let's do d point just because it's a data. But then it also needs a make d points because it needs a constructor if it's data, right? And this is also valid. We can write this, right? But then if we want to get x, let's see, dx. Then we need to say mkd point p, and then we can do p point x. Does it make sense?
Yeah.
Right, because this is just an alias, right? But this creates a new type, right? Which the name of the type is d point, and then this is the name of the constructor. So we need to unwrap it here, right? Let's also, and the difference is some point here is just x value 1 and y value 2 or whatever, right? And this is correct, and then you can say get x of some point, right, for some int, right? So use is some int get x this of some point, right? We just put them together and that works, right? And here some d point, Okay. And this, in order to do this, we need to do mk, right? The point of some x1 and y2, right? Because like here we construct it, right? And here we pattern match or deconstruct it, right? To get back the inner record. And then if we want to use it, we use d. It's also an int. But then we have to do something like get dx over some d point, right?
Yeah.
Why can't I? Okay, there we go. Right? The main advantage when you do this, right? So when doing this, we can define instances for this type. Right? Whereas for this, we cannot define instances for this, right?
Yeah.
Okay, so let's try to combine these two things, right? So let's actually I'll say that homework starts here because this is like a prerequisite, right? And I will ask you to write instances for d point, for example, right? So 1, write print instance for d point. Okay.
Yeah.
Write a equal instance for the point, and 3, write a compare. So let me think. Where the x is more important. What does that mean? So okay, so what does that?
It has the priority, right? So
exactly. So if x is greater than y, if x1 is greater than x2, then the first point is bigger, right? And only if they are equal, then you look at the y's.
Yeah, exactly.
Okay,
yeah.
Cool. So you got it. Cool. So we write instances for those. Okay. Okay, let's look here. Ooh. Let me think. Do you think yeah, you should be able to. If you get stuck, then just ask. Okay, so
yeah, this time I promise I'll ask you.
So take the list int type from lesson 3. Declare declare the 3 instances above for it as well.
Okay.
Right, so you need to be able to print, to compare, to like see if they're equal, and to compare to list of ints. And again, same idea applies. List 1 is greater if I'm not done, by the way. So list 1 is greater if okay, how do I explain this? So if I have a list of 1 or 3 and 2 and 5, this will be greater than 2, 10, 10, right? Because the first element, like if the first element in first list is bigger than the first element in the second, then we're done, right?
Yeah.
It's kind of like here, right? So first element greater in first different element decides comparison, right? So but like if you have 3, 2, 5 and 3, 2, 6, then the second one is bigger, right? So it's like so.
Yeah.
Right, but if you have it like the one above, then you don't even look past the first thing because you already know the result. And then, of course, they're equal if each element is equal, right, until the end. And also, like, for example, if you have 3, 2, and nothing versus 3, 2, 5, then obviously the longer list is always bigger, right? Even if the value is like 0 or whatever, or negative, it's still, like, if it's longer, then it's always bigger. Okay, and then 5, do the same for tree int, which is going to be somewhat harder, but yeah, good luck.
Okay.
Okay, so let's think about one more thing here. Hmm. Okay, let's do class. No, that's too hard. I want you to try to define a class, but let me think about what it should do, right? Oh, I know. Okay, so 6. Think about and define a class that can work over to list int to or can concatenate to list int or to tree int. Did we actually write a function for concatenating two trees, or were we lazy?
I don't think we did.
Find tree map. No, we didn't, right? Okay, so instead of that,
One right one fast or what?
no.
No?
Or
Huh.
two. Oops, what did I do? I locked my thing. Okay, or two list string. That's fine. We have list string, and even if we don't already have it, we have to concatenate for two lists, right? I'm pretty sure we did that.
Yeah.
So if we can concatenate two, and again, if we didn't write it for list string, then it should be very easy to write. Correct?
Yeah. I don't think we concatenated this section.
Yeah, we do. It's okay. We didn't. Ooh, we didn't.
No, I don't think we did.
Okay. Not very hard to do, but then again, I've done it a million times and you've never done it, so it's easy for me to say that it's not hard. Okay, do you want me to write it for you, or do you want to try to do it yourself now?
Let's go.
Okay, so I guess let me copy this for you here.
Yeah, thank you.
The type, so you'll need it here anyway, so I'll just paste it here because you'll need it for that exercise, and then just I'll help you with this part, which is just the type, right?
Yeah.
Right, so given two list ints, we need to get a third one. That's the result of like putting them together, right?
Yeah. So
okay.
now okay. So I have to go for the empty.
Yeah. Well, wait.
What?
So you have two list ints as input, not just one.
So it's empty, or
sure. Yep, that's one case.
Okay, so now I have to pattern match it.
Okay. Okay. Okay.
Okay, and
maybe do a new line so we don't like.
Okay.
And then some spaces, like some amount of spaces. There we go. Whatever. That's fine. Okay.
Okay, and now I just go int 1.
Well, what's the type of the result?
The type of the result is a list int.
So how many types of list int do we have?
Only we have 2, but I
it's
only
either
need 1.
It's either empty or make list, right? So when you're concatenating two lists that are not empty, the result cannot be empty, right? So it has to be make list, right?
Yeah.
Okay.
I got it. And it's make list of so I don't have to use parentheses, right?
No, you don't.
No.
Well, I mean,
but,
I'm not sure what you're
like
trying to write, so let's see. Okay, sure.
So I think it's like this, and then
Well, like these are integers, and this operation does not work over integers. It works over strings and it works over a lot of other things, but it doesn't work over integers.
Okay, but if I go like this,
Well, the problem is that makeList wants an integer as the first parameter, and you're making a string here.
okay.
This is tricky. This is a tricky function when you try to figure it out for the first time.
Okay, so I want to concatenate to
So
int.
okay, let me give you a small hint, which will not be code. So I'll not show you any code, right? So you remember that we were writing lists like this, right? So this is list 1, 2, 3, right? And then we want to concatenate, and let me put like this operation for concatenate plus plus, right? And 4, 5, 6, right?
Yeah.
And we want the result to be 1, 2, 3, 4, 5, 6, right?
Yeah.
So in your case, the first time int 1 will be 1.
Yeah.
And int 2 will be 4.
Yeah.
So if you're trying to make a list where you put together like 1 and 4, you'd probably end up with something like 1, 4, 2, 5, 3, 6 or something, right? Which will not be correct. So it's yeah.
Okay. Okay. So
it's correct so far. Okay.
wait. I mean, this is what comes to mind, but I guess it's not correct, right?
Well, not really, because this doesn't work over list insider.
Yeah. So this one, okay.
So let me think.
I'm gonna need int 2 anyway, but
so let's work over this example for a bit, right? So we're trying to do this, right? 1, 2, 3, and then 4, 5, 6. Let's do just 1, 3, and 4, 5, because we don't need something that long anyway. Let me remove this and remove the 3 as well. Well, 3, 4. Right? Okay. So we kind of want the result we need to be is mk list 1, right? And then mk list 2, and then mk list 3, mk list 4, right?
Yeah.
And now in your example for the first step, we have int 1 equals to 1, right?
Yeah.
We have list int 1 equal to just 2, like the list 2.
Yeah.
We have int 2 equals to 3, right?
Yeah.
We have list int 2 equals to 4, I think, right?
Yeah.
So what does that mean? Well, in order to do this, I think we look at this. We need to do make list, right?
Yeah.
With 1, which is what? Int 1, and just 1. That's the only thing we need to put there, right? As the first argument. Correct?
Yeah.
Okay. So do you want to write that down just so we don't forget?
Yeah.
So no, I mean like here, right? So for example, make list int 1, right? So we know we have to do this.
Okay.
And then we need the parentheses, right? Okay. So now
do I go recursive?
Yep. Okay.
Okay, so now I concatenate list in.
Yes. So this works over 2 lists, right?
Yeah, so and now I go for int 2, like. No?
Okay, and okay, so okay, let me remove this for a second, and let's say that we have to put one list, so L1 and L2. We need to put 2 lists here, right? Because that's how concatenate list works, right? Okay, so let's look like so we have this part, right? And we need to create this part.
Yeah.
Right, and we need this as a result of concatenating two lists, right?
Yeah.
And we need to put 2 first, but we already have 2 as a list here,
Okay.
right? And if this also had a 10, then this would be also 10 here, right? And we need this to be here, like mk list 10, like in parentheses here, right? So it's not always a single value. So then the like L1 means that it needs to be list 1, right?
Yeah.
Okay, so you don't know, fill that in there so we don't forget.
So I need int 1
instead of L1 here.
Yeah. I just
Okay.
1.
It's list int 1, right? It's the list.
Yeah.
Okay. So what do we want as the rest here?
I want int 2 and list int 2.
Yeah, but we want them as a list, right?
Yeah.
So how do we get a list with that?
So I go mk list.
Yes.
Int 2.
Yes.
And list int 2.
Yep, except you need to parenthesize this whole thing.
Oh.
In this case. No, from mk list, starting with mk list.
Yeah, so this with the construct.
And yeah, this is the way we implement it. But there is a simplification we can do here. Let's see, is this actually an error, or why does it? Okay, so we still have an error, but let's ignore that for a second. So we are pattern matching here, and then we're reconstructing here, but it's the same term. So we could just say here, list 2. Like so.
Okay.
Right, because there's no point to open it up just to wrap it back again the same way. Right?
Yeah.
And then it's saying that we're missing a case. And the case is, okay, so we have here, okay, so if the first is empty and the second is empty, we return empty, right?
Yeah.
And then if the first,
if one of them isn't empty?
Well, here, when we put list 2, then list 2 could be empty and it's fine. Right, we don't care. Because this will work if list 2 is empty.
Yeah.
But what if the first, what if the, so the error is saying, what if the first list is empty and the second list is not empty?
Yeah, so I have to write the other case.
Okay.
Right?
Yeah. So the case is when the first list is empty and the second list is not empty. Okay. Are you sure?
What am I doing wrong?
So let me give an example, right? So you're saying that if I have an empty list and I concat it with the list 1 and 2, I get an empty list.
Yeah. Okay.
But what should I be getting? I should be getting
the second list.
You need to give it a name. You can't use underscore.
Yeah,
so you just give like L or whatever. Yeah, there you go. Okay, so you want to save now? Let me try to save it. So now it compiles. And okay, there is one more simplification we can do, right?
Yeah, I can delete the first line.
Yep.
The first
Perfect. That's what I was going to say.
As soon as I started writing the second one, I saw it.
I mean, I didn't expect it to see that. I'm surprised. Good job. Because it's not trivial, like, because you kind of like, okay, it's like, well, like, it's not an easy thing to see. Yeah, good job.
Thank you.
Okay, cool. So this is how you do it. And the way it works basically is you're kind of like, if you're looking here, you're kind of like unwrapping the first list, right? And constructing it until you're at the end of the list, right? And then when you're done, you just put the rest, like the second list at the end.
Yeah.
Right, so it's kind of going, okay, so if I'm doing 1, 2, plus 3, 4, right? We're kind of doing it one by one, right? So instead saying put 1 there and then put 2 there and then put 3, 4.
Yeah.
Right? And it kind of works that way because of the way the constructor is created, right? Because we always have a rest at the end, right? So that's why you have to like unwrap the first one by one, and then when we're done, we just put the second list at the end. Okay, cool. And I think, like, for example, you could have a case like this for performance where you have L1 empty equals to L1, because if you don't have this, then it like you'll unwrap and rewrap the first list for no reason. if the second one is empty. But this is just a performance optimization. I don't really care about this, so I'm not even going to allow it there, because I'll explain if you ever want to. We can do some lesson where I tell you about how you can optimize and how you can look at performance and so on. But that shouldn't be your concern when you're writing code as a beginner, especially. Like just write things that work. Don't worry about how fast they are for now. Okay, so let's delete this thing because it's going to confuse us later. Okay, so this is how you concatenate a list, right? So what I want you to think is, how do you make a class that has an operation like this, but kind of generic operation that would work on both list int and list string? Right, so I want you to write a concatenating class or something, right?
Yeah.
So let's see. So I want you to write class concatenating or something, right? So A, where some operation like concat is something, and you have to figure out what works here, right? And I want you to then define instance for the concatenating list int for list int, right? And I want to you do the same for list string.
String, yeah.
And of course here you have to do like where, right? The whole syntax, and then define the same concat there, right? And then I want you to like right, to write the instances. That's all I want, right? And then we should be able to do something like concat for mank list 1 empty and mank list 2 empty, and I want to get the list of 1 and 2, and I also want to be able to use concat mk string list 1 empty, and I think it was empty ls or something.
Yeah.
And empty ls here, right? And both of these should work, right, with the same function, because we define it here, right? So you need to figure out what the type is, and then to implement them. And normally, like, this implementation would be like this, right? We already have one of them, right?
Yeah.
You can just reuse this or type it again or whatever, right? And here you have to see if it works the same or not, right? Okay, cool. Okay. Yeah, and okay, so then one more thing. 7, could you define an instance of concatenating for int where we add numbers, right? Think about it, and if you can't implement it,
okay.
Wait, actually no, let's do like 7 for string where we just do this, right? Because this is string concatenation.
Yeah.
Could you define an instance of concatenating for int? Yep, I'll keep this here. Same question, but for booleans using the operation AND, right? Spoiler, you should be able to, so try to get it working, right? But also think about why does it work, how is that a thing, and why is that a thing, right?
Yeah.
Yeah, I think that's it. And the thing is, this has a very good reason of existing here, because next time we'll literally look at something like I think the most important part of the lesson is this concatenating part for me, because this will literally slide us right into the next lesson. Like if you figure this out, you kind of figured out the next lesson on your own, at least part of it, right?
Got it. Yeah.
Okay, I mean, yeah, I think that's pretty much it for today. So unless you have questions right now,
Mm, I don't think so.
Okay, then yeah, just don't be shy to ask questions anywhere, anytime in like on Discord or whatever. Yeah, I think that's it for today then.
Okay then. Well, thank you for having me.
Yeah, thank you for for being my guinea pig. Okay,
Goodbye, guys.
yeah,
Good night, lad.
okay. Good night. Bye bye.